Alright, we're being asked to simplify after we multiply this algebraic expression. First thing we're going to do is take care of this exponent right here, and we're going to apply that to each of the factors inside the parentheses. What that does is it multiplies all the existing exponents by 5, and importantly for 4 and 3, I'm going to think of it as a 3 to the 1 power and a 4 to the 1 power. So applying that exponent right there will give me a 3 to the 5th, an x to the 50th, a 4 to the 5th, and a y to the 45th, right there. And then I'm multiplying that by this expression 4 to the 4th, y to the 3rd, over 3 to the 3rd, x to the negative 7. Alright, next thing I'm going to do, I wouldn't have to do this, but I like doing this, it helps clean things up for me. I'm going to move this factor right here. And I'm going to use the property of negative exponents to do that. And what that means is negative exponents always mean reciprocal. And generally what that means in this case is I'm going to move that factor, that x to the negative 7, up to the numerator here, and it's become an x to the positive 7. Okay, so let me rewrite that before I move forward. So I have 3 to the 5th, x to the 50th, y to the 4 to the 5th, y to the 45th, and over here I now have a 4 to the 4th, a y to the 3rd, and an x to the 7th, and then a 3 to the 3rd down there on the bottom. Alright, next thing I'm going to do is I'm going to just multiply stuff straight across the numerator and denominator. I'll show the denominator on that first. So multiplying these two denominators together, what I'll just get is a 3 to the 3rd, a 4 to the 5th, and a y to the 45th. Basically just taking each of those unique factors and lining them up just from smallest number to biggest number, and then in alphabetical order. I'm going to do the same thing up in the numerator here. I'll get a 3 to the 5th, a 4 to the 4th, and then my x's, what I'm going to do are combine these two together. When I combine those factors, what I do is add the exponents. So it'll be x to the 57, and then what do I have left? Just that y to the 3rd. Alright, so I've combined it into one. Basically just multiplied those together. Now what I need to do is simplify, and I'm going to cancel any common factors. And there's a couple different ways to attack this, but I'm just going to talk my way through this. What I'm going to do now are one by one. First with these 3's here, I'm going to cancel the common factors. I have a 3 to the 5th in the numerator and a 3 to the 3rd in the denominator. When I cancel the common, there's 3 common 3's between these. What I'll get is 2 of the 3's left in the numerator. And that's important they're in the numerator, but it's because they're originally 5, so there's more in the numerator than was the denominator. A good example of that is if I look at the 4's now. Alright, now when I'm analyzing the 4's, I have 4 4's in the numerator and 5 4's in the denominator. I'm going to cancel 4 of those in each the numerator and the denominator, and what that leaves me with is 1 4 down in the denominator. Now I look at the x's. There's no x's in the denominator to cancel with the numerator, so I just get this x to the 57 right here. And then the final move is to do some canceling with my y factors here. 3 of the y's in the numerator and cancel 3 of them in the denominator, leaving me with, let's see, 42 in the denominator. If I wanted to multiply these numbers out, which I don't necessarily need to, I could just clean it up to look like this. 9 x to the 57 over 4 y to the 42nd, and that is as simplified as that can get.